Now, that was one industry trend, but there's another industry trend that's been going along, and 90%, 80% of the audience, judged by the arms that went up, will understand the concept of open source software. Software without patents that people can take, use, improve, on the main condition that if you improve it, you make what you've done as an improvement available without further restrictive license terms. So how many people in the room think open source software is a good thing?
Yes.
Okay, so I have to be careful what I say further on down the presentation. However, in the last 2 or 3 years, there's also been a move to open source designs for hardware. So this machine, which is built basically out of MDF, bolts, and somewhere in the middle there is a wooden router that you use for taking shapes out. The plans to make that are available open source, and although I'm not 100% sure how big that is, if you're talking about a baby one, sort of desktop size, they're cost a couple of $100 to make. This is early days yet, but this is a reasonable sized laser cutter, and the plans for that are available on the internet. The guy hasn't got as adventurous as saying how much he thinks it can be made for, but you know, these things sell for tens of thousands of pounds if you buy the commercial versions. This is the what I describe as the main competitor to the printer that we've built. This is a thing called Fab at Home. It doesn't self-replicate, which is I'll talk about that a little bit more further on in the presentation. So it's a device that you make. Kits typically cost about $2,500, but its big plus is that this thing here is a syringe, but you can put different things in. So if you want to make something out of ceramics, you put your soluble clay ceramic type material in there, and it'll build you a 3D shape out of that. Take it, stick it in the oven, bake it solid, hey instant teapot. And in terms of the multiple uses of this technology, I think Fab at Home is currently pushing the boundaries, because there isn't I might call it a distraction, but because there isn't an objective of having one machine make another. People have actually focused very much on what you can do with them, and all the open source innovation is really going into the stuff you can do with that. So there are people doing food, there are people doing low melting point metals, ceramics, plastics, etc.
Human organs.
Yes, that's somebody did a liver. That was the what's the really exclusive club in the States. The doctor has actually printed using stem cells and stuff, printed a replacement liver or bladder for somebody. They've actually transplanted it into them. So let your imagination run, basically. But this is the one I like best. These things called GVCs. So they're global village construction sets, and the idea behind this movement is that they're building open source plans so that you can run your whole village or your whole community. So if you want a tractor, if you want a feed hopper, if you want a car, they've got open source plans for it. And I really don't know how far this movement's going to go. I mean, obviously their main interest is in the third world.
To the first lawsuit.
I don't know. Because a lot of car technology or tractor technology's got to be out of patent, hasn't it?
Doesn't mean I would try.
Well, there's patent trolls all over the world, but and then finally, to get to the machine that we've been building and playing with, this gentleman here, who's the godfather of the printer variety called RepRap, because his interest is, well, one of his interests, because he's pretty much a polymath, is this subject called biomimetics, which is biological systems methods, but using them in engineering. He said, what if you made a machine that could repair itself? And of course, if it can repair itself, you can build another machine with it. And so, you end up at the rep wrap. Now, because a company called Stratasys had trademarked, that's the right one, isn't it? The IPR lawyers over here. Previous term, FDM I think it was, is their trademark, so you can't use that. So the open source version of FDM is Fused Filament Fabrication, FFF. The object of the exercise was that the machine could make as much of itself as possible. Currently that's mainly making the plastic joints that hold the whole structure together, and the other sort of key points of bonding the various components of the machine together. But there is already work going on to print circuit boards. So people have actually used low melting point metals and printed something that will conduct electricity on a substrate and use that to power a device. And ultimately, who knows, they might end up printing the threaded rods. I don't know how far you can take it, but I think it could go quite a long way. But the key point about the fact the machine can print itself is really that you don't have the problem of capacity of machines. I mean, in the old days, if you had a factory, the biggest thing that impeded your expansion was how much it cost you to get some more machines into your factory. Well, the machines basically cost as much time as it takes you to build the next machine now. And there is a theory which I am inclined to feel is taking it to the most absurd point, but that these machines will cost nothing. So they're completely automatic, they'll make themselves. I think that's a bit like expecting the world to be overrun by rabbits. Yes, in the right conditions they can breed exponentially, but other factors come in and reduce the limits. So it's food for thought, and it makes for good presentations to policy wonks, basically, and strategy wonks. But this is the practical instance of what the ability to self-replicate means in terms of evolution and mutation. Hannah and I started out 5 years ago trying to build one of those, and, well, in my opinion, that was a bugger to build, if you'll excuse my French. We failed at the electronics. We started off trying to build the electronics, then we were going to spend the money on the structure, because you see there's an awful lot of metal in here, and we thought that might be a lot more expensive.
How big is that?
Sorry?
How big is that?
Well, if you go and look at the machine over there, which is sort of that, by that, these things are normally specified in terms of the print area, and that's the size of object that they can print, and that will print something like 8 by 8 by 6 inches. Sorry, I'm old enough to remember inches. This has got the same print area, and the big difference in appearance between these is this had a lot of metal in because you've got the box structure and then you've got the bracing bars, whereas by going to this triangular structure they made the whole thing a lot stronger and eliminated an amount of metal and therefore cost. So this version's called Darwin, because we're in the realms of evolution here. That one's called Mendel, and that's, I'd say that's the current big model. This is a baby. It's I was hoping that we'd have one of these to bring to the presentation working, which would have saved us lugging this bit of a beast to lug around. That's smaller, has a print area of about 6 by 6 by 4. But there's been sort of significant changes. One of the main ones, this doesn't actually have the extruder head in. This is the bit that melts the plastic. Saying that's the bit that melts the plastic up there. The bit that melts the plastic is missing on this, but it would actually be fed from a motor that's not mounted on the machine. So the amount of weight that's being moved around is greatly reduced. But that's mainly to enable the machine to be more compact. This is the fourth of the official version. So for those of you who are software, this is probably Debian. This is whatever came before Debian. That's Red Hat, and that's Puppy Linux. People have taken the same concepts, they've done different things with them. And this, the main thrust behind this is to make this as efficient and simple as possible to produce. So there's fewer components. There are more motors actually, because that reduces the need for quite a lot of the belt drives and gearing and stuff. And 5 years ago there was that one only. This, say 2 years ago, became the standard version, the current version, and in the last 6 to 9 months you've now got these two new kids on the block. So the hare that Adrian Boyer set running is definitely running, because these things don't happen by themselves. People are actually putting lots of effort in. Now, in order to get to a stage, and this is really explaining a bit of jargon, because I've talked about rep wraps, but another word is a rep strap, and a rep strap is the machine that you have to build in order to print the first set of plastic parts. Now, that one I can get my head around, because there's a guy who's basically taken a couple of bits of chipboard and used a lot of metal, and then he's done something pretty sophisticated here in terms of milling the parts to make an extruder head out of metal. But this is using blocks of wood and bolted it together in the right place, and the extruder is built in exactly the same way. And I just think that is apparently, and we bypassed that. I have to say we cheated, because we bought a set of parts that somebody cut using a laser cutter. I don't think I could have got my head around building that, to be quite honest. But that is the official bootstrap machine on the RepRap website at the moment. So if you want to do it the fully religious way, you have to start by building one of those and then go to one of the 4 versions on the previous slide. And I wish you good luck. I wish you good luck.